Hello everybody, my name is Ignacio Torrens and I'm pleased to present you our work titled Plug and Play Modular Facade Construction System for Building Renovation to Achieve Nearly Zero Energy Buildings. Driven by climate change, nations worldwide are responding with incentives and regulations to guarantee a more sustainable future. These measures generally focus on the reduction of emissions, the increase of renewable energy penetration, and energy efficiency. The building sector is responsible for 40% of the primary energy consumption in Europe. Moreover, 90% of the residential building stock is minimum 30 years old and 40% of it older than 60 years. These numbers show a significant potential and opportunity to satisfy European objectives. One of these initiatives is the renovation wave from the European Green Deal program that tries to accelerate renovation rates. This initiative promotes the research and adoption of technologies that will help buildings be more energy efficient, ideally going towards zero energy or even positive energy buildings. Industrialized construction shows great potential and can support these goals. The work we show today presents the development of an industrialized facade and the steps we undertook to accelerate the process to bring it from research around a TRL of 4, as can be shown in the graph, to close to market, a TRL of 8 to 9. This presentation will try to highlight the most important aspects of the facade system definition, the installation assessment of its prototype in a testing facility, and the use of this facade system in the renovation project of a residential building in Spain. As mentioned before, this plug-and-play modular facade overlaps the existing building without removing its original envelope. A prefabricated solution based on an aluminum frame anchor at the existing wall incorporates thermal insulation and an external finish. The system presents the following functions: the addition of insulation, an improvement of the envelope airtightness, a replacement of existing fenestration, and an integration of solar systems and efficient HVAC systems. The plug-and-play modular facade is suspended from brackets previously anchored to the original building structure, as can be seen in the picture. The combination of the fixing system plus the possibility of prefabrication of the facade significantly reduces the time required on site. This fixing system allows for the adjustment of possible irregularities in the support. This adjustment can be seen in some of the pictures in different axes. Large facade areas can be installed quickly and easily in a short period of time with this method. After designing the facade system, a prototype was manufactured to be installed in Cubic, which is a test facility in Spain. The objective was to assess the physical installation and test its thermal performance. The test setup consisted of a 2-floor facade section with an area of more than 20 square meters. Prototype facade included opaque panels, as can be seen in the picture, and a smart IoT window. Let me show you a video of the facade installation. The installation time was significantly lower than for the installation of a conventional ventilated facade, and as can be seen in the video, scaffolding was not really necessary. It's not really necessary in this system, and this reduces greatly the cost of auxiliary equipment. The facade installed requires a scissors lift and a mobile crane. We can see in the video how the layer of brackets was installed previously, then the insulation layer, and then the prefabricated facade. The full installation procedure was tested, including the installation of anchors to the facade, hanging of facade elements on them and sealing of junctions, and the validation of critical connection points in the installation process. Once the facade prototype was validated in a safe testing environment and feedback was given to the designers, the same system was planned to be used in a real renovation project. This is the renovation of a social housing building with 6 dwellings in Durango. It's located in Durango, Spain. The retrofit of the facade will span over 196 square meters, and it consists of 75 opaque panels, 30 panels with windows, 20 photovoltaic and 6 solar thermal panels. Previous construction works validated that the fixing system was reliable and replicable in buildings with flat roofs. In buildings with a pitched roof, the vertical displacement of the panel for its fixation on the facade is not possible. A specific connection system for this reason was designed to hang the panel so that it can be fixed to the facade, avoiding the roof overhang. You can see a picture, an image of such a system that we developed to be able to overcome that issue. So for the results, based on the results of an energy simulation, the improvement achieved is predicted to be 60% energy use reduction, 80% CO2 reduction, and the system of the solar panels are able to provide 20% of renewable energy. It is also expected to obtain significant reductions in cladding materials, insulation boards, and construction waste. And for the conclusions of this work, the developed facade system allows for simple and significantly faster renovation of buildings, contributing towards reaching the near zero energy consumption goal. It has been verified that the execution times and actual equipment needed are greatly reduced. The fixation system developed for the facade allows for the adjustment to common irregularities in existing walls. A structural analysis of the existing walls is necessary to ensure its load-bearing capacity, and a detailed analysis for the seamlessly integration of the new facade and the original building is required. This would need to consider integration details such as wall-to-roof junctions and window openings. The work here presented took place within the nZEB project, an Horizon 2020 project, and under the collaboration of several institutions. Well, thanks very much for your attention, and that was all.